Okay, hello again, everyone. Here we are at part two of our lecture for today. And this final topic is quadratic inequalities. Now, that would be an inequality that would involve a quadratic function. So if you see x squared, that's the clue that you're looking at a quadratic inequality. Perhaps I got x squared plus 1, is greater than x minus 2. Yep, that's a quadratic inequality. Now, when you're solving a quadratic equation, you might notice what you do is you isolate 0 on one side. So if I have a quadratic equation, and for example, if I've got x squared is equal to x plus 2, that's a quadratic equation. Unlike a linear equation where you isolate and solve for x, the quadratic equation, you isolate 0. Okay, we're talking about equations right now. We're going to come back to inequalities. You isolate 0 on one side. So let's see. So I'm going to get x squared minus x minus 2 equal to 0. That's step 1. Okay, now step 2 is then you use either factoring or the quadratic formula to solve it. Now, similarly, if you're solving a quadratic inequality, so let's look at an example here. Suppose I have x squared less than 6 minus x. There we go. That's the quadratic inequality we're going to look at solving. Step 1, isolate 0. Let me write that down. Step 1, isolate 0 on one side. So I'm going to get x squared plus x minus 6 less than 0. And therefore we want to solve that. Now, one approach you can always take is graphing it. Hey, graph it and look at when the graph lies below the x-axis. Graph it. We want to be aware of this procedure, but this is not actually how we're going to do it. So graph it. Let's see. So I'm going to go over here to Desmos. And here I have x squared plus x minus 6. We want to know, when is this negative? All right, so here's the graph. And you can just take a look at it and you can see, well, it's going to be negative when you're in between -3 and over to 2. It will be negative. Hey, now, the problem with this approach is you've got to graph the entire function, and that's more work than is necessary. But you can always resort to this. Graph it. Of course, we don't have Desmos next Tuesday during our exam. And in fact, hey, if I call this function g of x equal to this, notice what Desmos will do. We get Desmos to solve this. G of x, when is that less than 0? Notice that Desmos gives you a visualization. Okay, less than 0. From -3 over to 2. There's the answer. Wonder what would happen if I change that to less than or equal to. Less than or equal to 0. Notice the difference. Less than or equal to 0, it contains the endpoint. See that solid line right there? So the answer is going to be -3 is included as part of the solution from -3 up to 2. Whereas if it was just less than, notice you got the broken line. Okay, now let's go back and show you how we are going to solve inequalities. To do that, we got to give you a very important definition. The book doesn't give this definition until chapter 4, but we're going to introduce it now. It is called a zero. Zero. What do we mean by zero? Here's a definition. R is a zero for some function f if f of r is equal to 0. Okay? That's what we mean by the zero of a function. It's any input that causes the output to be 0. Now, we might notice that R is also known as the x-intercept. So if you're graphing a function, the x-intercepts occur at zeros. And another important fact about zeros, if you're dealing with a quadratic function, if R is a 0, x minus R is a factor. Most likely we kind of know this, but we get to prove that in chapter 4. So let's give a simple example. Suppose I have, it doesn't have to be quadratic, but suppose I have f of x is equal to, hey, I'll go with this one that we just did. X squared plus x minus 6. Let's find the zeros for this. Could be more than one. So to do x squared plus x minus 6, I set that equal to 0. I want to factor. This is x plus 3 times x minus 2 equal to 0. I'll use the zero factor properties. So I have two zeros. One's at minus 3 and the other is at 2. Those are my zeros. And if you went this way, if you found out that these were your zeros, then these would be your factors. That's what we mean by a zero. Okay, then we now want to introduce something called a zero plot. Now a zero plot, I'm going to use the function x squared plus x minus 6, and I'm going to construct a zero plot for this. A zero plot is the following. You draw the real number line, right? And then what you do is you plot the zeros. Now the zeros were 3 and negative 2. So I'm going to come over here, 1, 2, 3. There it is. There's my 1, 0. Put a little 0 there. And negative 2. Minus 1, minus 2. There it is. It's only two things I want to show. Okay. That's not the whole picture on our zero plot, but that, hey, to construct a zero plot, find the zeros and plot them. Hey, before we continue this example, let's do another simple one down here. F of x is equal to x squared minus 1. Oh, do the zero plot. Here we go. You set that equal to 0, and you know the answer is plus minus 1. So over here at 1, I have a 0. And over here at, 1, 2, 3, I got a minus 1, I have a 0. That's the beginnings of a zero plot. Now, for quadratic functions, it turns out if this is a zero plot, what this plot does, if there's two zeros, it divides my number line into 3 segments. 1, 2, 3. I'm going to show the 3 segments. From minus infinity up to minus 2. From minus 2 over to 3, this segment. And finally, from 3 up to infinity. Whenever you draw your zeros, you're partitioning or dividing the number line up into so many segments. If there's 2 zeros, you're going to have 1, 2, 3 segments. Over here, 1, 2, 3 segments. Now, something about these segments. The function under observation on these segments does not change sign. It's either always positive or always negative. It can't change sign. Like over here, if someone claims, oh, for these values my function is positive, but then here it's negative, you say, wait, that's impossible. because it can only change sign. For it to go from here to here, it's got to go through a 0. There's no zeros over here. This is the only place where it could change sign. So what I want to do is figure out for these 3 segments if the function is positive or negative. And to do that, we sample the function. We sample it. We choose some value in one of these segments. Now I'm going to choose 0. 0's in here. And I'm going to look at what f of 0 is. Okay, so I'm choosing 0. Someone could have chose something over here. Let's get rid of this. So, and I'm choosing 0 because it's usually easy to see what the function is at 0. Hey, at 0, f of 0 is negative 6. The function's negative here. It's negative between here and here. All these values, functions got to be negative. Can't change sign. It only hey, but then you see a 0, so it's changing sign. So it's positive over here on this segment, and it's positive here. That's the 0 plot. So the 0 plot's not just showing where the zeros are, it's showing what the sign of the function is. Now once you have this picture, which is supposed to be easier than graphing a function, now you might remember from Desmos what this function happened to look like. It looked like this. Came down, did this, and came back up here. Okay. Well, the idea of the 0 plot is we don't have to graph it. We got all the information we need now to solve the inequality. Now if I'm asking, hey, where's this function negative? Where's this function 0? Where's it positive? All the answers are right there staring at me. Now, as maybe you've solved quadratic inequalities before and you have another way of doing it. There are other ways of doing it. But please, this technique is what we will be expanding on when we do polynomial and rational inequalities. So we're introducing this technique now because it's absolutely necessary in chapter 4. So now, hey, I've got this function, and my question was, let's go back down to this problem. We had the problem which was, here's the inequality, was when is x squared greater than 6 minus x? So now I'm going to solve this inequality. What we do first is isolate 0, which is x squared plus x minus 6. When is that greater than 0? Construct the 0 plot. And that will tell you. Construct 0 plot. Well, hey, how do you do that? Fine. Well, we did it right here. So now when I want to ask when is this greater than 0, it's if you're in this segment or this segment. Okay. If we say greater than or equal to 0, you would include this. So when is this thing greater than 0? That's the inequality we're looking for. Right now, greater than 0. I might have wrote earlier less than 0, but this is fine. When is that greater than 0? It's going to be from minus infinity, this segment, over to minus 2, or if you're from 3 to the right. There, we have done it. We have solved a quadratic inequality. There's your answer. Let's do another one. Okay. Suppose we have 4x times 1 minus x. I wonder when that's greater than 0. Now notice, hey, this one we have plotted on Desmos. I'm not going to plot this. When is this thing greater than 0? 4x times 1 minus x. And you say, let me construct the 0 plot. So step 1 I've already done. I've got 0 isolate. So I take 4x times 1 minus x, set it equal to 0. It's going to be 0 if x is 0. It will also be 0 when x is 1. So here's a 0 at 0. Here's a 0 at 1. Now the next step is I need to see what the sign is for these 3 intervals. Let me again label my 3 intervals or partitions. Here's one, it's called minus infinity up to 0. The other one's from 0 to 1. And finally, we have one from 1 up to infinity. So think about this function. Whatever it looks like on this partition, the sign is the same. The sign, S-I-G-N. It's either positive or negative. Positive or negative, positive or negative. So what you do is we can just choose any value inside one of these. I'm going to choose 2. I'm going to choose 2 over here. And remember, we call a sample of function. So I'm just choosing 2. Some of them I chose negative 2. So I'm going to choose 2. So let's see what f of 2 is. F of 2 is 4 times 2 times 1 minus 2. That's 8 minus 1 times 1. It's negative. This function is negative here. It goes to a 0, so it's got to change sign. It's positive here. And it's negative here. That's the 0 plot. Now, looking at that, when is this thing positive? Here's the answer. From 0 to 1. That is your answer in interval notation. Try another one. Hey, so this is solving quadratic inequalities. Okay. I have another one. X squared. When is that less than minus 2 minus 3x? Quadratic inequality. Well, let's solve it. It's quadratic. Isolate 0. X squared plus 3x minus 2. Hey, we've always been doing, let's do a less than or equal in this one. Less than equals 0. Okay, try less than equal. Okay, what do we do? Hey, step 1, isolate 0. Step 2, construct 0 plot. Find the zeros. X squared plus 3x. See, this is new. Zeros, we're going to be talking about them a lot. Future lectures. Set that equal to 0. Oh, that's a plus 2. Solve a mistake here. Set that equal to 0. Hey, this is factors. This is x plus 2 times x plus 1. So my zeros are negative 2, negative 1. Negative 2, negative 1 makes this 0. So over here at negative 2, there's 0. Over here at negative 1, there's a 0. Now we just got to see what the sign of the function, sign, positive or negative, on these intervals. I'm going to, hey, whenever I got a choice, I like to evaluate it at 0. So I'm going to say, hey, that's my, one more time, we call that, we sample the function. Sample it. I'm going to sample it at x equals 0. There's no use sampling at negative 2 or negative 1. You know the function's 0 there. So you're going to sample it somewhere on one of these partitions. I'm going to sample it at 0. And the function is 0. It's staring right at us. It's 2. This is 2. So it is positive here. Negative here. Positive here. But now we're asking when this function is less than or equal to 0. So the answer is going to be from minus 2 to negative 1, but you include those points because it's 0 there. Here's your answer. Well, that concludes, that's all we need to know for now about quadratic inequalities. We showed you how to solve them using a zero plot. We did 3 examples. Let's go take a little look at one of these examples. X squared plus 3x plus 2. Let's look at that one. We want to find out when that one was less than 0. So I'm going to go over here. X squared plus 3x plus 2. And there's the function. When is it less than 0? Oh, from -2 up to -1. Sure is. And you can get Desmos to solve it for you. Great. That's great. Now, we have exam number 2. Tuesday. It's our first exam, and so we have to start it's just the first half of the class. Because of our lecture being 2+ hours, we can't use a whole class period for the exam. So there will be a lecture that will follow. We have the exam first. You need to bring scratch paper with you, some extra paper to show your work. That's all you need to bring. Paper, of course you bring your calculator. And remember the exam's closed book, closed notes. Okay, bring some scratch paper, bring a pencil, bring your calculator. And any questions about that exam, please email me. I've noticed I'm getting emails on Canvas. And so you're not supposed to send emails using Canvas, just send them directly to my email address. So that concludes our lecture for today. And again, feel free to contact me by email with any questions. And we are signing off.